This is 10-1 study guide page 2, exercise number 1, finding the distance between 2 points. I do not use the distance formula. You can if you like. It does work, but you have to just make sure you follow the subtraction and addition sign correctly and use parentheses. If you don't, you will get the wrong answer. So I do it a little bit different. I graph all the points they give us. So for number 1, they give us the points 3, 7, so 3, and then up 7. Again, I'm not trying to be perfect here. I'm just getting a general idea where it is. And then -1, up 4. Okay, so again, not exactly perfect. Now, they want to know the distance that's directly between these two in a straight line. Okay, but like the midpoint, I actually am going to measure how far over and how far up between those two. That makes a right triangle, and I can use Pythagorean's theorem. So this was 1 to the left here, and then this one was 3 to the right. So if we have 1 plus 3, that's a total of 4. This was already up 4. You know, this was -1, comma 4. And this was up at 7. So I went from 4 to 7. So from 4 to 7, 7 minus 4, that's a distance of 3. So we have a right triangle with 4 and 3 as the legs, and we want to know the hypotenuse. Hypotenuse is always c. And so we do the Pythagorean theorem, a squared plus b squared equals c squared. So in this case, that would be 4 squared plus 3 squared equals c squared. And we want to know what c is. So 4 squared gives us 16. 3 squared gives us 9. I leave it as c squared. 16 plus 9 is 25, equaling c squared. And to undo a squared, you take the square root. So the square root of 25 would equal c, and the square root of 25 is 5. So it turns out that the distance between these 2 points is 5. Now, don't always think that it will be this one, and one more gives you the hypotenuse. This is a very special triangle. It's called a 3, 4, 5 right triangle. It will come up sometimes. But for example, if this was 6 and this was 7, this would not be 8. That would not give us a right triangle.